Hi guys, this is a reshoot of chapter 1.7, the review 2 questions. Because the last time I did it, I had a brain fart and I was doing, instead of cube, I was doing the cube root. So sorry about that. Principles remain the same though. Let's start with the original function graph. So if you look at this function, I'm going to do 21 first. The original function is a cube function, right? So that one got passed right to the center. And then if you think about 1 cubed, when I cube it is still 1. -1 cubed is going to be -1. So I have -1, -1, and 1, 1. If I cube 2, 2 cubed is 8, right? 2, 4, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Somewhere over there. And then on the bottom side, -2, and then 1, 2, 3, 4, 5, 6, 7, 8. So this is the original function graph. And then we're just going to basically apply the transformations to the original. So let's look at this. Let's look at what's going on here. This is the, what do you call it? The transformed version, right? So remember my recommendation when graphing these, find your starting point. The starting point would be the origin here. Here, -1 close to the x means it moves 1 to the right. Plus 4 at the end means 4 up. So let's redo this thing. Okay. Here's my x-axis, y-axis. Instead of starting at 0, 0, it's going to start 1 to the right and 1, 2, 3, 4 up. So right there. Okay, and then, so that takes care of this part and that part. Now what else is happening? I have a -2 in front. And notice that's before the cubic happens, right? So if you look at this, that -2 is before the main function is applied. So it's close to the x. That means it's a horizontal change. So first of all, in terms of reflection, because it's a negative, the graph is going to reflect over the y-axis. So it's going to reflect this way. Yeah. So if I reflect it that way, the new picture, instead of going up to the right, it's going to go left to the right. I'm sorry, not left to the right. It's going to go up to the left. So something like this general picture. Yeah. And then what does this -2 do? Remember, -2 is a stretch because it's close to the x. It's a horizontal stretch. So it's doubling, right? So normally, think about it this way. Normally, from my starting position, I would go up 1 and left 1. But instead of going up 1 and left 1, I'm going to go up 1 and left 2. Wait, I think I said that wrong. Okay, I'm sorry. So the other thing to remember about horizontal stretches is if it's a number that's bigger than 1, we always stretch by the reciprocal, right? So we're actually stretching by 1/2. So normally where you would go up 1 and left 1, now I'm going to go up 1 and left only 1/2. So that's going to put me right over there. And then normally when you go right 1 and down 1, and I'm saying right and down because remember we have this negative part, so we're flipping, right? So normally we go right 1 and down 1. You're going to go right only 1/2 and down 1. So it's going to look something like that. Okay, and the next step, where normally I would move horizontally by 2 and go up and down by 8. I'm going to only move horizontally by 1 and up and down by 8. So that means from my starting position here, I'm going to go left by 1 and then up by 8. So 1, 2, 3, 4, 5, 6, 7, 8. Right here. Okay, and then similarly to the right, I'm going to go right by 1 from this starting position and down by 8. So 1, 2, 3, 4, 5, 6, 7, 8. Right there, those spots. Okay, so I've taken care of the original translations, right? This -2, and that's everything. So now I'm just gonna plot those points together, graph the thing. We'll do that in red here. So it looks something like this. Something like that. Oh, that's supposed to cross through this point here. So something like that. It's like a stretched version of this, right? Compressed version horizontally. So these parts were brought in, and then these guys were also flipped over the y-axis, I mean, yeah. So it's flipped over the y-axis, and that's the result. Now, if you want to be absolutely certain you are where you are, or to be more accurate, you can actually just maybe label some of these points. So this point here, the starting position, that was +1, 4, yeah? And then this intercept right here, that one is 0, 4 up plus another 8 is 12. This position here, that's, let's see, 1, 2, -4. So that's 8 down from the original starting position. Okay, there you have it. That's question number 21. So let's do question number 22 now. All right. Question number 22. So this time we're graphing an absolute value function. Let's start with the original. Just a reminder what the original function is. Oh, I'm sorry, shucks. I forgot to state the domain and range again for that last question, yeah? Let's go back to that. Let me just draw a quick sketch of what I had. And the only thing I really need to know here is where I started, right? I was at 1, 4. And then I remember it went up this way and down that way. So looking at the domain, this is going to go forever to the left, forever to the right. So domain for that number 21. Sorry, this is 21 now. Domain is going to be everything, -infinity to +infinity. And similarly, the range also is everything, because I can go as far up as I want and as far down as I want. So the range is also -infinity to +infinity. Okay, domain and range both -infinity to +infinity. Okay. So now let's double check we answered the question. Graph the function using transformation, state the domain and range. Yeah, okay, now we finished it. Let's go back now to 22. Let's go back to where we were saying we're going to do. We're going to graph the original function first. That's the absolute value function. Remember the absolute value function? That's not straight. Starts at the origin, right? Because absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of -1 is also +1. So you get this V shape like this. Something like that. Okay. So that's the original function. Now what's happening here? We'll start with the translations. So the +3 close to the x, that means the translation 3 to the left. And then this -1 after at the end, that's a translation 1 down. So I'm going 3 to the left and 1 down. Yeah? So 1, 2, 3 to the left, 1 down. That means my starting position of the V is right there. Here's x and y. Okay, now what else is happening? I've got a -2. That's it. But look at this time, the -2 happens after the absolute value is already applied, right? So that means this time it's a vertical flip. So this is going to reflect this way over the x-axis. That means it's going to open downwards like this, right? And this time the 2 also after the absolute value, that means it's a vertical, vertical stretch. So instead of going, normally I go over 1 and down 1, but I'm going to go over 1 and down 2 now. Okay, so that's going to be 1, 2 like that. Like this, opening downwards because it's a -2. And left 1 and down 2 as well. So it's going to put me right there. Yeah. And then otherwise, same picture. I'll connect the dots there. It's not straightening out that for me. Let's try again. There we go. And this guy like that. Yeah. Okay, and you can label some points here just to make sure we know what we're talking about here. So let's do the points in red here since I did the graph in black. This is -3, -1. This point right here, -4, -3, and this is going to be -2, -3. Okay, the domain, x values, every left and right, I can go as far as I want to the left, as far as I want to the right. So the domain it's going to be everything, negative infinity to positive infinity. And then the range, if you look at the range, up and down values, I can't get any higher than that value, but I can go as low as I want. So it's going to give me all the way to negative infinity. It's as far negative as I want to go, but it's going to stop once I get to that point at -1. So -1 is the highest I can go. Yeah. Negative infinity to -1. Yeah, and just like that, that's it, done. So sorry about the reshoot. Just again, the correction was last time I did this, I didn't do a cube, I did a cube root for some reason. That's just a brain fart I had. So sorry about that. Thank you guys. Hope that helped.